Okay, it's an hour about the Axelrod model. So far, yesterday I speak about several models. Today, I will focus in the Axelrod model and how it's work, how it's stated as a model of cultural dynamics, and how then get used to use as a model of mass media influence. And if we have enough time, I'm going to tell you about our last work with Sebastian about how to try to understand the dynamics of real mass media. So let's start. Understanding how culture get established, spread, and be sustained, it's very important. I'm trying to make the point in which, make the content in which this model was formulated. So in the question or in the paradigm between homogeneity and diversity, we could be in favor of homogeneity in certain aspects because for instance, in language, everybody here, we can speak a sort of English language, is in favor about our communication. But homogeneity also has the problem that we don't like when the small culture get destroyed. So the problem of homogeneity and diversity in cultural environments is a problem that has been studied during many years. And it's very relevant to the process become similar or retain their differences. It's very useful in this kind of process, as for instance, state formation, succession conflict, transnational integration, domestic cleavage, etc., etc., etc. So one of the persons that takes this problem and he proposed to study was Robert Axelrod, Bobby Axelrod. This is not the protagonist of Billions. He is a professor of political science. He did a PhD in political science, but he graduates as a mathematician. So he asked this question. So as I said yesterday, the series in the 70s was currently focused on the social influence and that people that are similar become more, tends to interact more often, and after interaction, they become more similar. So the question of Axelrod is, with these dynamics, why everyone, we do not finish or equal? Why this state has to end in a collective state that has to be homogeneous? How can diversity arise with this mechanism? And this is the problem we are going to study today. So first, we have to define the elements of the model. In this context, the term culture will be used to indicate a set of individual attributes that are subject to social influence. This culture is a set of attributes that can change because social interaction. The meaning of this attribute is not specified in the model. And the question being investigated here is how people influence each other on a given set of features and why this influence does not lead necessarily to homogeneity. This is our starting point. There were previous explanations for this, the problem of diversity and in cultural environments, like social differentiation, fad and fashion, preference for extreme views, drift, geographical isolation, etc. But the transfer of ideas occurs more frequently between individuals who are similar in certain attributes, such as belief, education, social status, and the like. So, the model of social influence that Robert Axelrod put on the screen is an abstract model about this postulate, this principle. So let's see how it works. The research question: under what condition and diversity of cultures? Under what conditions can a diversity of culture be created or maintained? In what are the mechanisms would lead to a culturally unique state, or under what condition would it occur? The proposal of Axelrod was investigating this problem with a nation-based model. This nation-based model is going to have local interaction that produce global behavior. This is familiar for us. There is no central authority. It's common in complex systems. It's going to be adaptative rather rational agents. I mean, in this model, he differentiates from the model frequently used in economic, when the agents try to maximize some quantity. They're rational agents. Here, there are no rational. They just follow individual simple rules that we are going to sketch. And the two pillars of this model are these two items. The interaction between people is more frequent and intense if they are more similar. This is homophily, and this is similar to the mechanism in the model of Massas-Flachet that I told you yesterday. And also, the interaction between people with a certain degree of similarity makes them more similar because positive social influence. And this is what is called social influence, and we were talking yesterday. So can these two mechanisms maintain or make our system to converge to an homogeneity global state, or can these mechanisms produce diversity? So this model is like this. We can have a grid. In every point of the grid, we place an agent. We have n agents. This is our agent, and this is surrounded by 4 nearest neighbors. Each one of these agents is characterized by a vector of, in this case, as an example, of dimension f equal 3 in this example. So each individual has 3 components, and every component can take 2 values. That is the amount of traits that we have in each feature. For instance, this feature can be, for instance, the language he or she speaks. Let's suppose that it's 1 for English or 0 for Spanish. Or could be his political state. It can be Democrat or Republican, for instance. And it could be the civil states, could be single or married. So if we put all the combination, we have all the possible state of one of these agents. It's okay? Other features can represent, for instance, work, operating system, drink, etc. The difference with the model we treated yesterday, that this is a model of these variables are nominal. There are not, we cannot define a distance between. The idea that 2 people have different features, different traits in a given feature, we cannot measure. We know that they are different, but we don't have an idea of how different they are. Of course, there are some works in Axelrod-like model with the metric variables, but we are not going to see this today. So how's the dynamic of the model? Well, the dynamic of the Axelrod is as following. Just we take at random an agent, and we pick at random one of the neighbors. and we compare the set of features just by measure the similarity. The similarity is how many features they have in common respect to the rest of the feature. For instance, the red agent has, and the blue neighbors, this has 2 features in common among 3. So with a probably 2/3, the red agent is going to change. Here is the blue agent. Is going to change the states from 1 to 0. If the state of both agents are this and this, so the probability of change, the probability of interaction is 1/3. It's okay? So I choose them, and one with a probability of 1 in 3, they are going to change or keep this feature. Yes. Only one. Every time, yes. One of the features that they are not similar, change one of the features becoming more similar. So every time they interact, they become more similar in one feature. And every time you have n steps like this, and this is a time step of the model. No, I mean, it's to set like, I mean, this is a toy model, just to test this mechanism. If you want to compare this, you have to give an answer about how many interactions you have in a day, or just put and scale it, what this means. But this is a very simplified model to compare with a real situation. I don't know how to put a time scale in this problem. In this basic model is pairwise interaction. Yes, it's true.
It's the only one.
Yes, you can. I mean, if you would like to try with a group interaction, it has to be some leader and something that the influence has to be over a group of people. But I have not seen group interaction with this model. There are a lot of variants, but that I have not seen that.
Maybe you can change the time scale and consider four interactions as one.
Yes, for instance. But if you don't have a comparison with a real scale, I don't know what that's. Yes, just simply, yes, you can, of course. And people has a lot of work around this model, but I have not seen group interaction with this specific model. So this is an example of how the evolution goes. We have here an Axelrod model with 5 features and with 5 traits by feature. Yes?
Just in the previous slide.
Yeah.
They became more similar. First, the probability of becoming more similar with 0, 0, 0, right? Could it be also 1, 0, 0, which means that you become more similar to the other guy?
Yes. No, but this is a choice. I mean, maybe this is symmetric. It doesn't matter which one changed their feature. Yes, it doesn't matter.
Pablo,
Yes.
I thought that in the Axelrod's model we changed the active agent, not the.
Yes, maybe here I made a mistake with the example. Yes, you should change the active one, but if you change the other. It should be the same, I mean. Yes, there are. It's okay? So let's suppose we start with a random initial condition, like here. In a case in which we have 5 features, and 5 traits for feature. I mean, every feature can have 5 different values. So this is initial state, random initial state. And the agent start to interact with these rules. Well, the dynamic of a system becomes, there are domains of similar people, and eventually no, this finish in an homogeneous cultural state. But if we increase the number of traits of each feature, instead of having 5 different values for each feature, we have 10 different values for each feature. What has happened is that it evolved, it started to produce domains of similar agents, but the systems cannot converge to a monocultural state. It is frozen between domains of different cultural states that are orthogonals. They cannot interact, but the probability of interaction is 0. So if we study a measure of order of the system as a function of the number of traits that each feature can take, we have a transition like this. This is a transition for 2 different size of grid between a monocultural state and a multicultural state. So when we increase the number of traits, these systems have a transition between an ordered state and a disordered state. So this was the point of Axelrod. I mean, I have a mechanism with this convergent local interaction. We still can have diversity because depending of the value of this variable, when we increase the value of this variable, it said that there are states that are orthogonals. They cannot interact each other. So can never become similar because they're so dissimilar that they're not going to homogenize. And the systems order in sets of different minor cultures, okay? Of course, this transition, if we fix, when I was plotting here, is the measure of order is the size of the biggest fragment of the dominant cultural state. So if I plot this size of the biggest fragment as a function of Q, we have a transition here, as I say, and this transition depends on the variable f. I mean, if I increase the number of features, it increases the critical Q at which we have the transition. Of course, there was people that was studying if this transition was a first-order phase transition or a second-order phase transition. This is a work from Matteo Marsili, Claudio Castellano, and Alessandro Vespignani from the year 2000. By the way, Matteo Marsili is going to be in StatPhys, so it's a great opportunity to hear about his work. And also, Maxi San Miguel, who is going to talk to you tomorrow and on Friday, he has a lot of work in this kind of Axelrod model. And together with collaborators, he has studied the transition in the Axelrod model in different kind of topologies, not only a grid. What they figure out here is that for 2 features, this transition is a second-order phase transition. And they say that for greater values of f, the transition is a transition of fair order, in which we have a bimodal. In the transition, we have a bimodal distribution of fragments. Yes?
The results depending on F are for which fixed topology?
This is for grids.
Square grids.
Yes, square grids, 2-dimensional grids. But of course, there are people that study the dependence of this transition with the topology. And of course, there is a lot of work of Maxi San Miguel, and you can ask him tomorrow and on Friday, because it was a very good opportunity to do that. Also, Maxi is going to present a work in StatPhys, so I recommend to hear. This is how this transition in the Axelrod model behaves in small word networks. Does anybody know what a small network is? Everybody? Does anyone don't know what a small network is? You. Small network, this is a small network is a network in which the average path between two nodes is very low. And the neighbors of a given node are very well connected. This is basically a small network, and the model of small network was very famous with the work of Duncan Watts and Steven Strogatz, that they established these algorithms to go from a completely ordered one-dimensional networks to a completely random networks by doing the simple process of just cutting a link and rewiring at random. When we rewire at random, it happened that it appear long-range links that they change dramatically the mean distance between any nodes. So and maintaining certain local order that is going with the clustering coefficient that we're going to talk later. So this is the kind of transition between a fully ordered and a fully disordered networks when you increase the rewiring process, the probability of rewiring a link. And this is for P about 10 to the minus 2, there is a random small word network. So Maxi and co-workers, they study the transition of the Axelrod model from different values of the rewiring probability, and they found that, of course, this transition depends on this rewiring probability. And also, they have this plot of dependent of variable of Q and how the critical Q, that is about 55 in regular networks, is increasing here when we increase the disorder in the network. When we increase the disorder, the transition is, we need more values of a larger value of Q to produce transition. They also study the transition in scale-free networks. I will speak about scale-free networks later. And here, they found scaling with the size of their networks. So they figure out that here, that they change the size of the networks, the critical value of the transition moved to the right. But if they plot the parameter of order against a rescaled Q with the size to the given power, we have collapse here as the way the Mauro showed. If we plot the same transition in the random network, we find also that we have a dependence with the feature, the number of features. This is a figure that Sebastian is doing for his PhD project. Also, we have also the same dependence on a fully connected networks. But what we found here is that we have a good scaling for this transition in lattice, but not in complete network, when we plot the order parameter against this quantity. And this quantity is the probability of having a link with zero homophily in the initial state. That is the probability that two features are equal is 1 over Q. So the probability that they are dissimilar is 1 minus 1 over Q. and the probability that two agents are completely different are 1 minus 1 over q elevated to the power of f. So if we plot in this quantity, that is mean that these two agents in the initial state have zero homophily. They are not going to interact. So they have zero probability to interact or to become similar. We have this scaling, but we are working in understanding what we have this scaling in lattice and not in a fully connected network. So if you want to know more about this and you are coming to the StatPhys, I recommend to see our poster in the StatPhys. That's why this course is a preparatory school for StatPhys. So. But the Axelrod model evolves. And evolves in this way. People use this model to ask this question: how I can model the influence of a given mass media? So if instead this vector represents different cultural state of a given person, I can think that this vector could represent different categories in which a newspaper is ordered. It's feature 1, it could be world news, the 2 politics, the 3 business, 4 opinion, etc., etc., etc. This is a New York Times, this is El País of Spain. So in this case, it's a New York Times about 20 different sections that it could be corresponded with 20 different features. And here, El País has 13 different features. So we would like to identify the mechanism, the efficiency by which different forms of mass media influence could induce or could work as a social influence process. And the first one was a Japanese researcher, Shibaini, with start to studies very, very close to the Axelrod model in the same journal, the Journal of Conflict Resolution, which he stated that they have to use a model formulation to study the type of problem because the previous approaches to the influence of mass media was related to how mass media change in the individual attitudes or individual or just in very few groups. And he said that this problem has to be studied in a group of people. And the model is a good approximation to do this. So the Shibaini hypothesis or the Shibaini model of mass media influence has 2 different postulates. The one is what he called the generalized other model. The other is the mass media. In the generalized model, other model, the mass media is represented as an extra neighbor. So each agent has a probability to interact with each one of his neighbors, but also with this extra neighbor. And he varies the weight of this connection respect to the weight of the connection. If this connection are weighted by 1, this connection is weighted by 0. It should be the regular Axelrod case to 8. And the way he thinks the mass media is a mass media that represents the preferent state of the population. And what he found is that counterintuitively, the dominant state is not 100%. I mean, when he put the mass media, the system is, intuitively, we will think that the mass media is going to impose his point of view. It's going to help to homogeneity. But this doesn't happen. So they prove another hypothesis to model mass media. That is what he called the filter model. in the Viertel model, the influence of a mass media is a more subtle mechanism. It's like a local mechanism. In this case, there is no an extra agent, but the mass media acts as a filter in local influence. I mean, the neighbors are influential only when they are accordant to pluralities. Pluralities is the state expected to the mass media. So it favors the interactions that are according to the dominant state, but in a local sense. Another approaches to model mass media influence are like this, are thinking that each agent can interact with a given probability with the mass media, and with the complement of this probability, each agent are going to interact with the classical Axelrod rules. And basically, there are three ways of model the mass media influence. For instance, I didn't find many more in this context. The first one is just think about a fixed mass media. It's a mass media that every elements are fixed in time. They doesn't change. And this acts like a propaganda. This is a fixed state that wants to impose its cultural state in a population. The second example is a global mass media, but where the features of this mass media are, in the sense of Shibaini work, adapted to have the dominant value of each feature of the population. Okay? And also, we can model like a local mass media in which the mass media is only defined by the dominant state of the neighborhood of a given state. I mean, the mass media doesn't take the dominant features of all the population, but the dominant features of the local environment of each agent. And what we see, this is a result of a work of González Abella. This is how the transition depends of the value Q and the probability to interact with the mass media. The larger is Q, the more intense is the interaction with the mass media. And here we see that the mass media is successful to impose his point of view just for very low values of V. But if we increase in this model the value of V, the mass media doesn't help to homogenization, but produce a diversity of multicultural state in places of the parameter space where without the mass media we have a monocultural state. It's break the counterintuitively, it breaks the monocultural state. This is some simulations just to see how the system evolved. This here is the color code of the mass media, and we can see how the agents are interacting, and the system became monocultural and on the same state of the mass media. So for these low values of interaction with the mass media is successful to impose his state. This is a fixed mass media. This is the result without a mass media. This is a classical Axelrod model. So the system should become homogeneous in one of the all possible monocultural states with the same probability. And okay, we have some simulation more here, but I think these two are enough. So we have here with the system converging to a monocultural state. And this is the parameter dependence of the solution for the critical V against C for these three different mass media modeling. So this is for a global mass media. This is for a fixed mass media. And here we can see that the local mass media is better to induce a monocultural state associated with the mass media. And this are the curves of the Orden parameter. This B equals 0 is the classical Axelrod model with the probability of the intensity of the mass media is very low. This is good for the mass media because it produces monocultural state in a wider region. We can see here that the local model of the mass media is much better than the global, but when we increase the probability to interact with the global mass media, it became very, very bad to produce homogeneity. So summarizing this kind of result, for B equals 0, the system settles in one of the possible homogeneous states that are Q to the F possible states. For low values of B, a fixed mass media imposes its state over all the elements of the system, but for higher values of B, the system becomes multicultural. And the global there is difference between the global or local mass media. The local mass media is more efficient to produce a monocultural state, so it's maybe it's a better strategy in this kind of simulation. The next step I want to tell you is about a publication that we have with Sebastian here that is part of his PhD, in which we twist a little bit this model. We maintain these rules. We have an Axelrod model in a two-dimensional grid that each agent could interact with the mass media or with probability 1 minus B with all the neighbors. But the mass media has a fixed feature, that is the first one, that is represent in some point the way of thinking of this mass media. And the idea is that the mass media is going to change the other features in order to increase the amount of followers of this editorial line of the mass media. So we assume here that the mass media influence the population with a given purpose. Yes, this purpose is to set the agenda in a given specific feature. And to achieve this, the mass media will adapt the other features. We are going to call followers to those agents who share the first features with the mass media. And we are calling non-followers to those agents which do not share the first feature with the mass media. And we are going to analyze two different strategies of the mass media behavior. The first one is what we call the follower strategy, in which the non-fixed component of the cultural vector, the mass media adopt at each time the dominant cultural state of the mass media followers. For instance, these four agents are followers of the mass media because they share the first feature. So the mass media is going to adopt the most abundant state in the feature 2, the more abundant trait in the feature 5, and the most abundant trait in the feature 4, and it is going to be the state of the mass media. Okay? So a non-follower that has not shared the point of view of the mass media in this more important feature, but he shared the other features, he's likely to become a follower of the mass media because share the same point of view in other features. The non-follower strategy is rather similar, but the mass media, instead of adopting the most abundant features of the followers, it's going to adopt the most abundant features of the non-followers. And the idea is the same. So our question was how the global state of the system depends on these two different strategies. And for asking this question, we are going to calculate the fraction of followers, the normalized size of the biggest fragment, and also to see how the system behaves in time to map the mean homophily between the mass media and the follower. I mean, how similar are the followers to the mass media, and how similar are the followers between them. And when we do that, we found this. This is the fraction of followers, and this is the size of the biggest fragment. We found 5 different regions. The first region is the absolute consensus, identical to the mass media. This is the follower strategy phase diagram. As we can see, it's very similar to the previous one. And we identify 2 different regions in where we have absolute dominance of mass media, a relative dominance of the mass media, and a complete fragmentation. And we have here a set of dominance in which the biggest fragment is a state that is completely orthogonal to the mass media. But the curiosity is that if we plot the non-follower strategy from the mass media, it's like this. With the non-follower strategy, the mass media is always successful to produce a monocultural state. So if we see the dynamics, we see here, this is the fraction of followers with different strategies. We can see for square is the non-follower. This is the fixed mass media that we use as a reference, and the triangle is the follower strategy. This is the fraction of followers. This is the similarity with the mass media. It is the similarity among the followers. So we can see here for 2 different values of Q. For low values of Q, they behave rather similar. But for high values of Q, we can see here that the fraction of followers from the non-follower strategy always goes to 100%. So the non-follower strategy is always succeed in convince all the agents to become similar to them. And this is the similarity with the mass media. And we can see here that the most successful strategy to produce that all the followers are the 100%, they're very, very poor in order to get an homogeneous state between them. They share the first feature with the mass media, but they are not very similar with the mass media until very late times. And also it happened with the similarity between followers. I mean, the non-follower strategy is optimal for achieving the 100% of followers in all parameter space. But the follower strategy and the fixed mass media are not so successful in achieving these followers, but they're very good in make a more homogeneous group of followers. I mean, different strategies produce different results. One is very successful to cooptate followers, but these followers are very similar between them. So the other strategy is not as successful in the quantity of followers, but the follower of the mass media they form a very compact a very compact group, a very homogeneous group. So we did it as we was work with this Axelrod-based model for pretty long time. But in that way, we ask, as we said before, what is the time scale of which is the connection with the reality of this model? And we think that we should, if we wanted to try to do a data-driven model, or a model that is more based in reality, the first step has to be how mass media behaves in reality. And to see how mass media behaves in reality, we needed to analyze real mass media. In the way to analyze real mass media is using what is called natural language processing. This is not modeling anymore. This is data analysis. Maybe next year or in 2 years, we have result a model based in real data. So when one wants to study the mass media influence, the problem does not start with the model of the physicist model. The problem starts right before by the milestone of this kind of study is what is called the agenda setting theory, and start with experiment during an election in the United States. That is the work of McCombs in 1962, in which they performed some experiments about the relation of the mass media consumption and the behavior of voters, and they measure how the mass media consumption can influence or not the behavior of the voter. But what is interesting to us in this way is that its agenda is a systematic compilation of topics presented to the public along with a degree of emphasis between them. So the agenda that what the media put to our consideration is a set of topics of discussion and a certain degree of emphasis in which is the most important topic and which not. There is also a lot of work about this statement and different way of study, like media bias and framing, direct and reverse agenda settings. Who set the agenda? The media or the public? Or the social network? In order to do that, in order to quantify this problem, what we do is just to try to design a quantitative framework to study the postulate of McCombs in quantitative terms. To achieve this goal, we made a 4-point research. The first point is data collection. How to download these articles of the different news outlets. Then we are going to use a mathematical description in terms of natural language processing, just to mathematicize the information contained in the text, and then try to perform some kind of dimensional reduction in terms of topics. Finally, how can we, in this framework, quantify the agenda? We did this with a newspaper from Argentina, and we take these 4 newspapers, Clarín, Página 12, Infobae, y La Nación, as about between 2,000 and 3,500 news articles for each one of them. And we represent each of them mathematically. If we join all the corpus of news,
one question.
Yes.
Did you choose all news from that paper's
All news from the political section of this paper. Only political section. We also work with different, but what I'm going to show you here is just from the political section. we represent each article, each text, like a vector of dimension f. And this dimension is about 500,000 of 500,000, no? More or less. The dimension of each vector is the amount of words we have in the whole corpus of news. So we have one component of each vector for each one of the words we have in the corpus. And this value of each vector represents certain degree of importance of the word in this article. The simpler measure of the importance of a given word is the frequency of this, of how many times appear this word. For example, if this is 20, it means that this word appeared 20 times. In that, this is not the usual approach. There are several words that are very common in one text, but are very common in all the texts, preposition, articles, etc., etc., etc. So, yeah, you could use exactly for any language you have. And the way to do that is what is called the TF-IDF weight, in which one term is frequency with a specificity. I mean, if I have a word which is very frequent in one text, but it's very frequent in all the corpus, this weight is going to be close to 0. But if this word is very frequent in this text, but it's not frequent in all the corpus of the news, this weight is going to be close to 1. So we have a representation of each document, each article, as a vector in which one term represents the importance of this word in this text. Are you okay with me? And we do the same for all the news of my corpus. So I can represent my data as a matrix of n documents by f terms. It's a very sparse matrix. So the next step is to perform a cluster analysis. I mean, I know that I have many news, but as we know, much of the news are related because they speak about a given topic. For instance, it could be talking about the elections or about I don't know, some political aspect or whatever we're going to see. And what we expect there is that similar nodes would use similar words with similar frequencies. I mean, they are not identical, but they have to share some degree of similarity. So we want to group them by similarity. There are various techniques to do that. We can just simply measure the distance of the articles in this space using a cosine distance, for instance, and perform some clustering techniques. But we do here is just, because it was easier for us, just to use what is called non-negative matrix factorization. In this non-negative matrix factorization, it's like a principal component analysis, but in non-orthogonal directions. And we found the directions in the word space in which these news are grouped. And these directions are going to tell us which are the topics, these directions are given by a combination of words. And this combination of words is going to be representative of the articles that are close to this direction. This is, so we are going to decompose our matrix of documents in the product of two matrices, one which give us the matrix documents by topics, and the other is the topics in the term space. This matrix of the topic space in the term space are these directions here. That is the combination of words that in which we have grouped some number of articles. And this matrix is going to give you the projection of each article over different directions. I mean, how degree of pertinence has each article with the topic 1, the topic 2, etc., etc. In order to compare the media agenda with the public agenda, with the public interest, what we do is to look in Google Trends and in Twitter the group of keywords that define every one of the topics and to see the search of these keywords in Google Trends and in Twitter, with the idea that if this look the relative searches of the people of these topics and compare the media agenda with the public agenda. When we do that, we found that we have almost 10 topics we decompose our corpus of news in 10 different groups of news. Then we reduce these 10 topics to 7 because 3 of them we realized that they are talking about the elections in Argentina. This is talking about a political party. This is talking about the other political party. And this is about election in general. And this topic talks about news related with the government action of the current president. With this one is related with what happened. These 2 that we group in one topic is related with a case we have in Argentina with a missing person that it disappeared during a repression. This is the prosecutor death, and this is with the incarceling of a social leader that is Milagro Sala. And these are group of news that appear when the former a former minister, planning minister, was put in jail. Also, the former vice president was put in jail. So we detect these different topics that group the news. And when we did later is just to go day by day and calculate the weight of every newspapers give each one of the topics. So to see how is the degree of importance of each topic in a day-by-day basis of each newspaper. In order to do that, we calculate the weight of a given topic as the weight of the documents in these specific topics times the length of the document. That is a measure of the importance. See, this topic is news is very important. It should be reflected in the length of the news, in the coverage of the newspaper. And this is a delta that just to do this in a daily based time. And if we plot the relative weight of the topics against of time, we have this nice plot. These nice plots are the agenda of the media. Here, they are ordered by weight and ordered by ranking. So the topic we have here on top is the domination topic in these days. There are the elections. Here, there were elections in Argentina for this time. The primary election and the general election is here, over some here, general election F. So we can see here how we can quantify the dynamics of the agenda of the newspapers to say how a topic is dominant, then other topics appear, then it's replaced by the older one. They appear this magenta topic that is the news related with a missing person, and we have a representation, a quantifiable representation of the agenda. And this is the public agenda. It's what people search in Google Trends or in Twitter in the same topics. And we can see here that there is some kind of correspondence, because when this time is dominant, but also we can see difference here. For instance, here this topic has more persistence here. Also, it should appear to appear before here. And there is also difference between Google Trends and Twitter. In order to have a quantitative measure of the agendas, we plot, given that, I don't know if it is view, but we can think this as distribution in this 7 space evolving in time. So at distribution, I can measure for each day the Shannon entropy. And as I measure the Shannon entropy, it will give me an idea of the diversity of the agenda. So if the distribution is flat, the entropy is going to be maximum. But if the distribution is peak in a single topic, I mean the agenda is dominated by a single topic, I expect that the entropy goes down. So if I plot the entropy against time, I can check what happened when I have these dropouts. What this dropout means? This dropout means that there is a topic dominating the agenda. There is a very important subject that is dominating the public discussion or the media agenda. And when we plot this radar plot, that is the radial histograms of the topics in this specific point, we found that there is 2 topics that appear to be very important. One is the election. As if you read the newspaper in election time, we'll see that almost all of the news are related with election. But also there is one subject that called our attention, or called the collective attention, what is this news related with a missing person. We also measured the distance between the media agenda and the public agenda in order to study if the public interests follow the media publication. And we did that calculating a measure of distance between both agenda. We use the divergence of the Janson-Shannon distance for measuring that. And what we expect is when this distance is maximum, we expect that in some way in these days, the public preference are separated from the media agenda. I mean, the public preference are different from what media is offering, so we focus here in the maximum, and we found here that this missing person topic was capturing the attention of the public in general. It was not reflected in the media. So what happened here, what happened with this, for those who are not from Argentina, what's in the Patagonia, near Bariloche, it was a riot of a very reduced group of people, and this person trying to escape from the police disappeared, and was 1 month disappeared. And given the history of Argentina, in which there is some concern about the role of the army and the police in the disappearance of persons in the last dictatorship, there was a very sensitive subject. And during a month, or during 2 months, we didn't know if that person was disappeared by the police or the military, or just was missing. So it was very, very important for us. So we here measure the relevance weight of this topic against time for the 3, for the media, for Google Trends, and for Twitter. And what we have here is this is the media coverage, and this is the public interest. And we can see here that the public interest becomes very relevant before the media appears to cover it. So when we see this, we thought this is a case of reverse agenda setting in the sense that this topic becomes first important for the public and then was covered by the media. Do the public set the agenda? It appeared that yes, but if we discriminate the agenda of the newspaper for each one of the newspaper, what we found is that one media, that is the smaller one, this Página 12, start to cover this topic well before the other two. So, if we plot here the cumulative coverage of all the newspapers, we see here that first, these newspapers, Página 12, start to cover the topic, and then this topic becomes to be relevant in Twitter and then in Google Trends, and finally in all the media agenda. So our data suggests that we do not have, there was a discussion in the agenda setting framework in which there is a direct agenda setting or reverse agenda setting, which is the role of social network for doing that. This is an open problem, but we can see here is it's not we should not speak about a media like a whole. We have different media, and different media can play different roles. So if we want to do a good model, driven-based model, and a model that reflects reality, we just first need to understand how a mass media behave. And the first one we learn here, as we can speak about a given mass media as a single entity, because different mass media can play different roles. Here, the smaller mass media plays the role of put this topic in the attention of a very active people that amplify this topic in the social network. And when this topic increases the coverage in the social network, they become relevant to the general and biggest mass media. So the dynamics of the mass media and the public attention should take into account these features. Yes.
The population that watches, that reads page 12,
Yes.
uses Twitter or Google, and vice versa.
We don't know. We don't know. I mean, Twitter is a very narrow subgroup of the population. Google Trends is more used. So we understand that we can have certain bias because the people that has Twitter or the search in Google Trends, of course, they have to have computer, and if they have computer, they have an account in Twitter. But we don't have, until now, we don't have any other approximation to measure how public express or look for their opinion. There is many limitation of this study, but
If
yes.
you have a computer,
Yeah.
do you buy newspapers?
We are not talking about buy newspaper. Okay, this work, I understand your point. This work has an hypothesis. We are just analyzing written newspapers, papers, but I have to say this. All these news, Infobae, which is one of this is a web portal. This is no printed version. So we assume that people maybe don't buy newspaper, but they read newspapers. And even if they don't read newspaper, I don't know in different countries, but in Argentina it works like this. If we tune the radio in the morning just to saw what's happening in your country, in the world, all the radio programs made these programs based on the newspaper agenda. So it doesn't matter if you read a newspaper or not. The topics you are going to consume are set by the main media in your country. That probably they have newspapers, radio, television, and they broadcast a given topics. We are analyzing now is that as a corporation, maybe these media groups, they may have a strategy that different companies in their corporation can play different roles. And we have this hypothesis because it also happened in media corporation in Europe, in way these media companies has free newspapers that they give for free in the metro, in the newspaper, and in some way they test some topics, and if they become very important, they could reproduce or give more importance in the more traditional newspaper. We think there is a I don't know the word, but there is a non-trivial relation between how the mass media can influence and can use different companies to discuss this. But we think that with the access of data and the help of these natural language processing techniques, we can study this kind of problem. Question?
We are in the round of questions.
Yes, I finished. This, I forget to say. I finished. This. There is another one. Just tell me. Sí, yes. Yes, this is called framing. And this we did this analysis, but we keep in the qualitative. We didn't publish because we observed this in a qualitative. You did the word clouds of these topics from different newspapers. We are going to see different words and different framing of the same topics. We start analyzing that, but we did it in a qualitative way. We would like to do that more quantitative, and for doing that, we are thinking strategies to have a good representation. But of course, it's very clear.
You mentioned that you had information about other kind of topics, not only politics.
Yes.
Did you find the same kind of phenomena in other topics?
Yes. Yes, we do that just for test the method. For instance, we did it with sport news or with international political news. But I mean, it appeared that one topic related, for instance, when we have analyzed this corpus with when Fidel Castro died, and with a single spike of news related with this, and then disappear. For instance, when you look at sport news, you have just spike of coverage related with, I don't know, whether there is a football championship or the world championship, something like that. It depends strongly of a scheduled event.
You see that phenomenon that you got a little kind of paper that media that began to cover a lot a topic and then
I don't know. I don't know if I understand your question. You say okay. Okay, Pablo.
The second time I heard you talk about this, and I was very impressed by the amount of work that is involved in it.
Yes.
And
This is thanks to Sebastián. That was
yes,
2 years working in this problem.
and the way that, like in your final plots, you show, I mean, you really get to crunch numbers and get something that we can see and have a visual.
Yeah, I mean, the visualization of the problem is a very important tool to understand it.
Yes, but I just want to get a better grip on how much of the work can run on itself and how much input it demands on you. Because, for instance, there are companies
Yes.
that do this kind of thing, that try to keep some kind of thermometer of what's going on in society.
Yeah.
And I take myself as an example. I would love to know how the political winds are changing in Brazil right now, because they seem to.
Yeah.
So how possible is it for you guys to just keep this thing running on more or less real time or on different?
Well, this is one of our. Yeah.
A new company to do this or.
Yes, we would like to do some real reporter of the media. I mean, we would like to do that, and we are just trying to. At least we are doing the closer things to this is just to post in Twitter every some degree of time, put the agenda of the last week, of the last 2 weeks in different tweets. But we would like to do that in real time. I mean,
some topics.
yes.
I know.
We
Martin,
need-
the Argentinian president.
Yeah.
I mean, the missing person will probably die out.
Yes, of course.
But the president of Argentina won't until to the end of his term. So can you just keep a web page in which you keep an update on this narrative?
Yes,
Something?
yes. I think we can do that. But we need time and people to do that. But what I have seen, there is a data a web page of the United States that is Pew Research, that is it's used to analyze data coming from census in the United States. And a nice picture they have is how the difference between the distribution of Republicans and Democrats was with the distribution of Republicans and Democrats. They are represented by a Gaussian-like distribution. And they have plotted how these Gaussian are falling apart at distance between each other based on the analysis of this census data. I mean, there is I think this techniques of natural language processing in the availability of data, they open a lot of ways to analyze.
But census data every year, so every couple of years.
Yeah.
You have it like.
Yes, data you have, but the collapse to a low dimensional description of the data, an informative, low dimensional description of the data is not trivial. And this is what, and also you have to have an automatized way to do that. So, I don't. We're trying to go in that direction. Yes.
Sometimes there is this belief that the politicians impose some political agenda and try to distract the public with sport news, for example. So have you checked if the sport news driving the public attention to the sport news and keeping
No, we systematically analyze just political news. I say but when we analyze sport news, there are driven mostly by the agenda of the sports. I mean, the coverage of football every Monday has a peak. For instance, meanwhile the championship is if we analyze a period of news when the World Cup, football World Cup appear, well, you have also a peak of coverage. I don't know if a politician could drive to any new sport.
They try to distract the people with.
And this is, I mean, you are, you have to prove that. I don't believe you.
If you can prove it with
No, we didn't do this kind of analysis. But
you can do it.
First, I think I have to have some measure of the influence of the politician of a given newspapers. I have to prove that. And then I have to measure the influence of a given news over the population. I have to do this. I don't know if we can do that. I don't know, Sebasi.
Then you need more PhD students.
We need people to work. So, any more question? Yes.
The Axelrod model
Yeah.
guarantee that the system will reach equilibrium or at least stationary state.
The only absorbing state in the Axelrod model is the monocultural state.
Yeah, but
If we put noise in the Axelrod model, no, it's not. The monocultural state is not stable. It's not stable, no, Seba? Yes, because you perturb two agents with orthogonal with a single flip, they become similar in one feature, and they can interact, and then eventually they are going to a monocultural state. Well, if there is any more question, we can go to the break, and after the break, we have the last lecture.